I'm not doing revision. I'm just telling you some questions for the practice purpose. Let the RMS speed of O2 molecule is visible now, right?
Yes, sir.
In a gas is U. If the temperature is doubled, if the temperature is doubled, and oxygen molecule dissociate into atom, the RMS speed will be yes U by 2, 6U, 2U, 1.6U. For the exam, I'll tell you by the evening. I'll tell you today by the evening, okay? Rishikesh, I think first no practice will come.
So what did you just said?
I said I'll tell you in the evening. Do it fast. Mass of O2 molecule is 32U. Mass of oxygen atom is 16U. So VRMS of O2 will be divided by VRMS of atom. What it was root 3 RT by M. So T of O2 divided by T of O into mass of O2 divided by of O. Temperature is doubled. That means T of oxygen is
Just
two
one the
times
question.
the T of O2. Temperature is doubled and mass of oxygen is half of the mass of O2. We can put the values of both. It will come out to be 2, 1, 2, 1. Please mute your mic. Root 1 by 4 matlab 1 by 2. V of O2 divided by V of O is equals to 1 by 2. So V of O will be equals to 2 times the V of O2. And V of O2 is U, so it is 2U. 2U. Please mute your mic. Understood? Do it fast, Sanika. Done? All of
So can you
you?
just scroll up?
So can you explain the last part, the VO2 upon VO?
See, I'll take it from the starting only. Mass of oxygen was 32, mass of O was 16. Formula of VRMS was formula of VRMS is root 3 RT by M. That means directly proportional to root of temperature, inversely proportional to root of mass. So this is O2. So this will be O2. Okay, this is oxygen. So this will be oxygen. This is how I kept the values. Now it is given that temperature of oxygen is double the temperature of O2. So it becomes 1 by 2, and mass of O2 is double the mass of oxygen, so it becomes 1 by 2. Overall it becomes 1 by 4, and root of that will be 1 by 2. Okay, so we can write VRMS of O2 divided by VRMS of oxygen is half. So just multiply this with 2, you will get the answer.
Okay, sir. Thank you, sir.
Done, all of you? एक और करते हैं ट्राई. 1 liter of nitrogen gas and 7 by 8 liter of oxygen gas at the same temperature and pressure mixed together. Mixed together. Relation between the masses m, that is molecular masses of two gases will be Yes,
So, what is the portion for the exam?
I'll tell you that in the evening.
Okay.
Then mass of nitrogen equals to mass of oxygen. कैसे? At same temperature and pressure, Amod, we should say it's directly proportional. Volume is directly proportional to mole. At same temperature and pressure, volume is directly proportional to mole. That is Avogadro's law. Avogadro's law. So V1 by V2 will be equals to N1 by N2. We can say V of nitrogen divided by V of oxygen to moles of nitrogen divided by moles of oxygen, that is mass of nitrogen divided by mass of oxygen, mass of oxygen divided by mass of oxygen. So everything is given. We have to calculate this ratio. Volume of nitrogen is how much? 1. And volume of oxygen is 7 by 8 is equals to W divided by 28 into 32 divided by W. ये गया 4 टाइम्स, ये भी गया 4 टाइम्स, 4 से 4 कट जाएगा. So mass of N2 equals to mass of O2. Very good, Sakshi, Amod. All of you understood this. All of you understood this? Done, Sanika? Padma? Akarsh? Done? Amal? Encilio? Kshetra? Done? Harsh? Johan? Okay. Root mean square velocity is given by formula root 3 p by रो मतलब होता है डेंसिटी। अभी मैं डी लिख देता हूँ, रूट 3 पी बाई डी, रूट 3 आर टी बाई एम, रूट 3 डी बाई पी, both 1 and 2. Which one it will be? Root means the velocity is given by first D. A. केवल ए कैसे कह सकते हो अमोद यार आप, ये तो हमें पता ही है, दिस इज द फॉर्मूला, हाउ यू कैन लीव दिस थिंग आई टॉट यू आल्सो। यू मे से सर ओनली बी, वो तो समझा जा सकता है, बट आप ओनली ए कैसे बोल सकते हो? जस्ट नाउ वी हैव सॉल्व्ड वन क्वेश्चन ऑन दैट आल्सो। अमोद, रूट मींस का वेलोसिटी पे हमने एक क्वेश्चन सॉल्व किया है, यू गिव मी आंसर आल्सो फॉर दैट, हाउ कैन यू से इट्स ए ओनली? I am not talking about C option. VRMS is equals to root 3 RT by M. For an ideal gas, for an ideal gas, अच्छा, D is equals to PM by RT. D is equals to PM by RT. So RT by M will be equals to P by D. So root 3 RT by M will also be equals to root 3 P by D. तो इसीलिए इसका आंसर हो जाएगा डी ऑप्शन. ओके, वेरी गुड. Understood.
So what is P and D here? I had lost my connection.
P is the pressure only, same as we had in the ideal gas equation. D is the density of gas.
Okay, sir.
VRMS velocity is directly proportional to square root of pressure. Increases with increase in pressure. True or false? ट्रू होता तो मैं आपको क्वेश्चन नहीं देता. इट्स क्लियरली विजिबल दैट इट लुक्स लाइक ट्रू. बट अगर ट्रू होता तो मैं क्वेश्चन देने की जरूरत नहीं थी. आप बहुत होशियार लोग हो, आपको पता होगा ये. बट दिस इज फॉल्स. VRMS velocity does not depend upon pressure because when pressure increases, density also increases. When pressure increases, density also increases. So I want you to remember this. When pressure increases, density also increases. When pressure increases, density also increases. So net change will be zero. Net change will be zero. ठीक है. So you may think after reading the equation कि VRMS velocity जो है वो pressure के directly proportional होगी, but ऐसा नहीं होता है. When your pressure increases, your density also increases. When both of them increases, so net change is zero. Understood, Sakshi, Sanjana, Rishikesh? Understood, Sakshi? ठीक है, ये चीज ध्यान रखनी है because after seeing this equation you may think कि VRMS velocity will depend upon pressure also. But when pressure increases, density also increases. And when pressure increases, density also increases. both increases by a common factor, so they will get cancelled out. There will be no change. If there is no change, VRMS will also not change. All of you. ठीक है, तो we have done critical temperature, critical pressure, in the last class. Critical temperature and critical pressure in the last class. Any doubt in this? We have done critical temperature and critical pressure in the last class. Any doubt in this? 21. And their relations with van der Waals constant. आज हम पढ़ेंगे critical volume. Critical volume. Volume occupied by the gas under critical conditions. Volume occupied by the gas under critical conditions. Critical conditions मतलब critical temperature and pressure. The volume occupied by the gas under critical conditions is called critical volume. Is called critical volume. Volume occupied by the gas under critical conditions is called critical volume. Okay. Understood? No. It will be denoted by VC. Denoted by VC. So now we know TC, PC, and VC. TC, PC, and VC. TC is actually 8A by 27 RB. Formula for critical temperature. Formula for critical temperature. Formula for critical temperature. A by 27 B square. Three B. Copy it first. What will be the value of Z? What was Z? What was Z? Z क्या था? Compressibility factor. Very good मंगेश, संजना, साक्षी. ठीक है, तो Z था PV by RT. तो उसको क्रिटिकल कंडीशन में क्या लिखेंगे? PC VC by RTC. Calculate the value of this. We know the formula. Calculate the value for this. We know the formula. A upon 27 B square into 3B divided by 8A by 27 RB और नीचे एक और R. 27 से 27 कट जाएगा, R से R कट जाएगा, B स्क्वायर से B स्क्वायर कट जाएगा, A से A कट जाएगा. Very good, Rishikesh. It is a constant. Does not depend upon gas. That means all gas behave similarly under critical conditions. All gas behave similarly under critical conditions. All gas behave similarly under critical conditions. Understood, all of you? Okay. Now we have two other temperatures. Boil temperature.
So just scroll up. Done, sir.
The temperature up to which real gas behaves like ideal gas. The temperature up to which real gas behaves like ideal gas is called Boyd temperature. Between PV versus P, we should get a straight line curve, right? So up to a certain temperature, real gas behaves ideal gas. After that temperature, real gas deviates from ideal gas. Real gas deviates from ideal gas. Up to a certain temperature, real gas behaves like ideal gas. After that, it deviates from ideal gas behavior. That particular temperature is called boil temperature. This should also be known. Then we have inversion temperature. Inversion temperature. Inversion temperature. Am I audible?
Yes, sir.
Generally, when gases expands, that is moves from high pressure region low pressure region, they show cooling. That is,
Excuse me, sir.
just wait a second. Temperature decreases. Yes,
So what is written after gases expand?
that is.
Okay, sir. Thank you, sir.
Anyone else was asking something? When gases expands, that is when they move from higher pressure region to lower pressure region, they show cooling effect. दे शो कूलिंग इफेक्ट. ऐसा क्यों होता है वो हम नेक्स्ट चैप्टर में देखेंगे. Why it happens that we'll see in the next chapter. अभी के लिए आप ये मान लो whenever gases expands they show cooling effect. ऐसा क्यों होता है that we'll see in the next chapter, thermodynamics. Okay. This behavior of gas inverts above the inversion temperature of gas. मतलब गैसेज शोज इन्वर्ट बिहेवियर. इन्वर्ट बिहेवियर क्या होगा? इन्वर्ट का मतलब क्या होता है? What do we mean by invert? इन्वर्ट का मतलब उल्टा बिहेवियर, राइट? एम आई ऑडिबल?
Yes, sir.
Sir.
इन्वर्ट का मतलब उल्टा बिहेवियर, दैट मींस दे विल शो समथिंग रिवर्स. सीधा बिहेवियर क्या है? दे शो कूलिंग. इन्वर्ट बिहेवियर क्या होगा? दे शो हीटिंग ऑन एक्सपेंशन. दे शो हीटिंग ऑन एक्सपेंशन. They show heating on expansion. But when it will happen only after the or above the inversion temperature of the gas. For every gas, there will be an inversion temperature. उस टेम्परेचर के ऊपर gas will show invert behavior. Any doubt till here? Any doubt till here?
Sir, can you explain the sentence in red?
I said, देखो मैं फिर से पूरा बता देता हूँ. Can't we explain this using Gay-Lussac's law? Yes, I will explain this in the next chapter. Okay, because I do have to take the adiabatic process. Okay, it is related to the first law of thermodynamics. But क्योंकि यहाँ पर सारे टेम्परेचर साथ में लिख रहे हैं हम, so I'm just giving you it here. Otherwise, it is a part of thermodynamics. ठीक है? Okay. So I'll take it from starting only. Generally, when gases expands, that is moves from higher pressure region to lower pressure region, they show cooling effect. जब गैसेस एक्सपैंड करती हैं तो कूलिंग इफेक्ट आता है, टेम्परेचर डिक्रीज होता है. ओके, बिहेवियर ऑफ गैस इनवर्ट्स. ये जो कूलिंग का इफेक्ट है ये इन्वर्ट हो जाता है क्या? when this process takes place above the inversion temperature of gas. When this process takes place above the inversion temperature of gas. For every gas, there will be a particular temperature called inversion temperature. Below that, it will show cooling, and above that, it will show heating. Okay.
Okay, sir. Got it.
Understood? एक बार try कर लेते हैं whether you understood or not. For example, inversion temperature of CO2 is 25 degrees centigrade. Expansion of CO2 gas at 20 degrees centigrade results in heating or cooling. Sanjana, I said that generally when gases expands, then they show decrease in temperature, that is cooling effect. Generally when gases expands, they show cooling effect. Generally when gases expands, they show cooling effect. But for every gas, there is a particular temperature above which when they expand, they show invert behavior. Above which when they expand, they show invert behavior. That is the heating behavior. Such temperature is called inversion temperature. इन्वर्जन टेम्परेचर क्या है? 25 डिग्री सेंटीग्रेड. अमोद, इन्वर्जन टेम्परेचर क्या है? 25 डिग्री सेंटीग्रेड, 25 डिग्री सेंटीग्रेड से ऊपर 30 डिग्री सेंटीग्रेड पर हीटिंग, 20 डिग्री सेंटीग्रेड पर कूलिंग। ओके संजना, general behavior that is cooling will be experienced under inversion temperature. इन्वर्जन टेम्परेचर के ऊपर जाएगा तो हीटिंग हो जाएगा। अंडरस्टूड संजना विद एग्जांपल? अमोद, यू अंडरस्टूड? आप ही ने बस हीटिंग लिखा था एक। ठीक है, एक और देख लेते हैं। हाइड्रोजन एंड हीलियम are the two gases which shows heating always on expansion. It means they have very high inversion temperature. True or false? Sanika, do it fast and then answer this question. संजना, इसको पढ़ो, बताओ whether it's true or false. सनिका, अमोद, कॉपी नहीं करना है, ठीक है, एक दूसरे का। If you are not getting it, please let me know. Always heating, that means any temperature is greater than their inversion temperature. Yes, should. That is why you said false, right, Tanmay? तभी तो आपने false बोला ना?
Yes, sir.
Always heating means any temperature is greater than their inversion temperature. मतलब उनका बहुत कम टेम्परेचर होना चाहिए, which means their inversion temperature is very, very less. Understood? Sanjana, Sanika?
So can I explain this again?
The question or the answer?
Oh, the answer.
The answer. Hydrogen and helium shows always heating. Heating can only be experienced when we are above their inversion temperature. right?
Yes, sir.
Heating can only be experienced when we are above their inversion temperature, and we are experiencing heating always. That means any temperature is greater than their inversion temperature.
Yes,
If
sir.
any temperature is greater than their inversion temperature, that means they must be having very low inversion temperature.
Yes,
तभी
sir.
तो कोई भी टेम्परेचर उससे ज्यादा हो रहा है. That is why it is very very less. और यहाँ लिखा है very very high, इसलिए false.
Yeah, got it, sir. Thank you, sir.
Okay, it will be denoted by. It is denoted by TI. उसका फॉर्मूला हो जाएगा 2A/RB. Increasing order of given temperatures is TB is greater than TI is greater than TC. True or false?
So scroll up. Done, sir.
Increasing order of given temperature is TC greater than TB greater than TI. False. Then Rishikesh, tell me the correct order also. Fast. Okay, very good Rishikesh. What about others? बाकियों को कुछ नहीं पता है. सनिका, संजना, पद्मा, तन्मय, अमोद, मधुरा. मैथ्स नहीं अरेंज हो रहा है यार. राघवी, यश. Put the signs also. Hiram. मंगेश. मंगेश. TI is equals to 2A by RB. TB is equals to A by RB. And TC is equals to 8A by 27 RB. A by RB कॉमन ले लेते हैं. 2 A by RB, 1 A by RB, and 8 by 27. A by RB, मतलब ये हो गया फॉल्स। एक्चुअली साइन अपोजिट होने चाहिए। दिस विल बी ट्रू। वेरी गुड सनिका, अमोद, जोसेफ, यश। यश आपने तो यार उल्टा कर दिया, ये है क्या? खैर दो दो टीसी लिख दिया। यश प्लीज टेक योर आंसर। व्हाट अबाउट अदर्स? मंगेश, साक्षी, संजना, यश, गौरव। Please, all of you give answer. Johan, Akarsh. Very good, Shifa. Done. Liquefaction of CO2 gas. Liquefaction of CO2 gas. Copy it fast. Just wait, I'll make it again. Copy it fast. Done, all of you? Done, all of you? This is gaseous form, this is gaseous form, this is gaseous form, and this is also gaseous form. This is liquid vapor equilibrium. Liquid vapor equilibrium. Liquid vapor equilibrium. Done. Okay. So we wanted to liquefy CO2 gas. We wanted to liquefy CO2 gas. And for that we increase the pressure. For that we increase the pressure. So we are increasing the pressure. Why the gas is not getting liquefied?
Because temperature is
Temperature is
less.
not as much required, right? Temperature is lesser than the critical temperature, right? Temperature is not as much as the critical temperature. Understood? At this point, at T1 and pressure P1, at T1 and pressure P1, we have critical conditions. We have critical conditions. Gas starts liquefying. गैस स्टार्ट्स लिक्विफाइंग गैस का लिक्विफिकेशन स्टार्ट हो जाता है now whatever pressure you are applying that has been used up for converting vapor to liquid or gas to liquid. Understood? Understood? Whatever pressure you are applying that has been used up in converting vapor to liquid. तो T1 पर लिक्विफिकेशन स्टार्ट हो जाता है. प्रेशर कितना रिक्वायर्ड होता है? T1. If you take temperature T2, At temperature T2, pressure required will be how much? Pressure required will be how much? At temperature T2, pressure required will be how much? Pressure required will be P2. At temperature T3, if you are at temperature T3, pressure required will be T3. Understood? Understood? इसको liquefaction condition कर लो. We have liquefaction condition. Liquefaction conditions. See, I said at temperature T1, pressure required is P1 for liquefaction. At some higher temperature, higher pressure is required for liquefaction. At some more higher temperature, more higher pressure is required for liquefaction. At higher temperature, higher pressure is required for liquefaction. Any doubt in this? At temperature T1, pressure required is P1. At temperature T2, pressure required is P2. At temperature T3, pressure required is P3. At temperature T4, at temperature T4, pressure will be P4 for liquefaction. For liquefaction. Just read it till here and let me know if there is any doubt. पहले यहाँ तक पढ़ो, बताओ if there is any doubt, we'll discuss it again. Please read it again. In this region we have only gas. But as we get the required pressure, gas started converted into liquid. And it happens till this region. Similarly, at some other temperature, higher pressure is required. Higher pressure, P2 is required for the liquefaction. Further, at higher temperature, P3 is required. Further, at higher temperature, P4 is required for liquefaction. Understood? Please say yes, then only we'll go ahead. T4 is critical temperature above which gas cannot be liquefied. Tc is the T4 is the temperature, critical temperature above which gas cannot be liquefied. However high the pressure is applied. Okay. तो उसके ऊपर there is no liquid phase. No liquid. Understood? Any doubt in this? ठीक है, मुझे बताओ at temperature T1 at temperature T1 and pressure P2, can gas be liquefied? बताओ. At temperature T1 and pressure P2, can gas be liquefied? Yes or no? At temperature T1 and pressure P2, can gas be liquefied? Sanjana. Tanika, very good. Shifa. Amod. Yes, I think नहीं यार. हमें कितना प्रेशर चाहिए? We want pressure P1. We want minimum pressure as P1 और हमारे पास उससे ज्यादा प्रेशर है. तन्मय. We want
Okay, sir.
pressure P1 minimum और हमारे पास उससे ज्यादा प्रेशर है. We have P2 and P2 is greater than P1, so definitely it will get liquefied. Okay.
Yes, sir.
रिवर्स कर देते हैं. At temperature T2 and pressure T1, can gas be liquefied? Sir, as we have more pressure, it will easily be liquefied. Easily liquefied का मतलब क्या होता है? Liquefaction is just a point that will be achieved earlier. It will be liquefied only. इतना ही बोलेंगे बस. ठीक है, जो काम P1 पे होगा वही काम P2 पर. At temperature T2 and P1, can gas be liquefied? No. Why? We want minimum P2. We have P1, but P2 is greater than P1. तो रिक्वायरमेंट फुलफिल नहीं होगी, इसलिए नो. अंडरस्टूड.
So please follow up.
Just wait. Above temperature T3, gas can never be liquefied. However high pressure is applied. Yes or no? Very good, Tanya. Done, Rishikesh. मधुरा तो यस बोल रही है. What about others? Above temperature T3, gas can never be liquefied however high the pressure is applied. Yes or no, Madhura? No से काम नहीं चलेगा. You should say no. अच्छा, you are saying no for the answer. It can be liquefied. No, it can be liquefied
Done, sir.
till T4. It can be liquefied till T4. Understood? No, it can be liquefied till T4. This you should give as answer. That will be better. Okay, Sanika, understood? You didn't answer for this. All of you understood this graph? ठीक है, यही वो कर्व है. This is the curve that we have read for Boyle's law. If you remember, अगर आपको याद हो तो यही हमारा Boyle's law का कर्व है. Rectangular hyperbola. Yes or no? Why we do not have liquefaction? Liquefaction क्यों नहीं पढ़ रहे हम इसके अंदर? Because the temperature that we are maintaining is greater than T4. इससे नीचे ही लिक्विफिकेशन खत्म हो जाता है. अंडरस्टूड? ठीक है, तो कंसेप्चुअली द थिंग शुड बी वेरी मच क्लियर. अगर रियल गैस में से क्वेश्चन आएगा तो कंसेप्चुअल आएगा. वॉट एवर वी हैव डन बिफोर, लाइक ग्राहम्स लॉ, डाल्टन्स लॉ, बॉयल्स लॉ, चार्ल्स लॉ, उसमें से थ्योरेटिकल क्वेश्चन, सॉरी न्यूमेरिकल क्वेश्चन आएगा. यहाँ पर कंसेप्चुअली इट शुड बी वेरी मच स्ट्रॉन्ग. अंडरस्टूड? ये खत्म हो गया. Now we have liquid state.
Sir, could you please scroll up?
Yes, Sanjana, T4 is the critical temperature, which is 31 degrees centigrade. Done? लिक्विड स्टेट में हमें ज्यादा नहीं पढ़ना है, दो इट हैज बीन रिमूव्ड बाय द एनसीईआरटी आल्सो, बट आप लोग तो 2022 अपीयर करोगे तो दे में री इंक्लूड द टॉपिक्स, तो इसीलिए अपन पढ़ लेते हैं. वेपर प्रेशर हमें बहुत कम चीजें पढ़नी है इसके अंदर. वी हैव टू रीड वेरी लेस इन दिस. वेपर प्रेशर, सरफेस टेंशन, एंड विस्कोसिटी. ये आपने सब पढ़ लिया होगा फिजिक्स के अंदर. Surface viscosity and vapor pressure. You have read all these things in physics? Yes, it is a part of this chapter only. हमारे चैप्टर का नाम था States of Matter. We have read only gaseous state till now. ठीक है. What do we mean by vapor pressure? What do we mean by vapor pressure? वेपर प्रेशर का मतलब क्या होता है? Anyone know? That is as expected. और कुछ बताओ. आपने उसी का संधि विच्छेद कर दिया. That was vapor density, Tanmay. For example, okay. For example, you have some liquid state and you are heating it. ठीक है, आप इसको हीट कर रहे हो. Okay, now because of heat, the particles will get converted into vapors. Vapors में convert हो जाएंगे. But as you have a closed container, they will hit the walls of the container and get condensed. Liquid में convert हो जाएंगे. When they get condensed, they will start converting into liquid again. लिक्विड में स्टार्ट होना कन्वर्ट कर देंगे. So first you had liquid, you heated it, so liquid becomes vapors. Now vapors, when collide with the walls of the container, they start converting into liquid. तो liquid वापस आने लग जाएगा. तो you will be having condensation and evaporation. At one time, rate of condensation and rate of evaporation become same. At that particular time, pressure exerted by the vapors of the liquid on the layers of the liquid is called vapor pressure. Under this condition, pressure exerted by the vapors of liquid on the surface of liquid called vapor pressure. Okay. Pressure exerted by the vapors of the liquid on the surface of the liquid is called vapor pressure. But important is when condensation and evaporation are in equilibrium. जब कंडेंसेशन और evaporation बराबर हो जाएगा, उस पॉइंट पर whatever the vapors you have here, whatever the pressure they are applying on the surface of the liquid, That pressure is called vapor pressure. Understood? Understood? Pressure exerted by the vapors of the liquid on the surface of the liquid under the condition of equilibrium. Under the condition of equilibrium between condensation and evaporation. Pressure exerted by the vapors of the liquid on the surface of the liquid under the condition of equilibrium between condensation and evaporation is called vapor pressure. ठीक, कॉपी करो, बाकी नेक्स्ट क्लास में करेंगे. That is it for today.
So please show the slide.
Done?
Yes, sir.
Oh.